Good evening, everybody. Welcome. Thanks for joining us today. Hope everybody's enjoyed their first day of reInvent so far. So today we're going to talk about how to boost the performance of your database-backed applications using ElastiCache. And by the way, you might be able to save some money in the process. So show of hands, who here would consider themselves a database administrator? Okay. How about an application developer? Nice. Who's already using ElastiCache or another caching solution to cache a database workload today? Quite a few of you. OK, great. So chances are when you think about caching, one of the first things that comes to mind is probably application performance acceleration. But I'm here to tell you about how caching can also reduce your total spend. So on this graph, we're going to plot a couple of different curves. On the x-axis, we have the query throughput measured in requests per second. And on the y-axis, the associated cost. So generally speaking, this first curve here is about scaling a database with traditional techniques. The more performance that your application demands, the higher cost that you're going to pay. So with this next curve, adding a cache to the database, it depicts the general idea. So when you're starting out, if your application performance demands can be met comfortably using a standard database deployment, adding a cache is going to increase the cost, and it's going to increase the application architecture complexity. It's probably not worth going down that path. But as your performance demands increase, and you need to drive more and more query throughput, namely read queries in particular, adding a cache can be a good way to boost performance and save money. So there's this inflection point here where adding a cache does just that. And that's what we're here to explore today. So my name's Joe Travellini. I lead the product management team here for ElastiCache. And I'm joined by Stephen Hans, who's one of our senior specialized solutions architects who focuses on ElastiCache. So we're going to go over how you can reason about this inflection point and whether you have any application workloads that fit the right profile of realizing this benefits. So here's what we plan to cover today. I'll begin by going over the traditional techniques you have to scale your databases natively, and then I'll also compare that to how you scale them using ElastiCache. I'll then go over a brief summary of ElastiCache as a service for those of you who might not be super familiar with it. And then I'll talk about the profile of workload at a high level that stands to benefit from adding a cache. I'll then hand it over to Stephen. He'll go deeper into some of the tools and techniques you can use to identify which of your databases are good candidates for caching, which query results are being executed against those databases that you might want to cache, how to map them into ElastiCache, different caching strategies, trade-offs between them, and even some sample code for updating your application to be cache-aware. And at the end, we'll have a demo that hopefully brings us all together. And time permitting, we'll have some Q&A. So let's hop in. So first, I'm going to begin by reviewing the two most common ways of traditional database scaling, scaling up and scaling out. So in most application architectures, you have client machines that are accessing persistent data that's stored inside a database. These clients could be traditional Amazon EC2 instances. You could have them running in containers, or you might even have them running in serverless functions. Clients are going to write data to the database, and then they'll be able to access it. So generally speaking, your database is going to perform better when there's less of a demand on it to serve I/O. So if you have read and write requests going against the database, it becomes saturated with I/O. All else equal, you can expect your database to have lower performance. So each of these database nodes has a fixed capacity to them that it uses to serve those read and write requests. Now, there are techniques you can use, too, to optimize the database itself, to tune it and reduce the I/O tax on the database. Things like increasing the I/O buffer size, which holds more data in memory. That's a form of caching, by the way. But even that has its limits. So when you've exhausted your limits, be it the fixed capacity of the hardware itself or some of the tuning techniques, you have a couple of different options at your disposal. Arguably, the simplest one is to just use a bigger box, right, to scale up, vertical scaling. Another option you have, too, is to scale out, to use database read replicas and scale horizontally to achieve higher levels of read throughput. Now, that's a little bit more involved than scaling up. It requires separation of duties, if you will. Your applications need to be able to handle reads and writes separately. But if you're able to go through that process, you will achieve higher levels of read throughput from your application perspective. Now, scaling out also has its limits. To use a database read replica, you're typically keeping a full copy of the data in the database and not just the data that you access most frequently. So you might be paying extra for cost to keep that full copy and not accessing all of it might not be maximizing your return on investment. However, if you are able to do this, you can get more read throughput from your database setup, and scaling out and scaling up can be used together in conjunction. So now let's look at another way to scale the database by using ElastiCache. So we've updated this example here a bit. You can see ElastiCache now in the mix. And your application clients can still read and write directly to the database as before. But now you have a distributed cache used to accelerate the performance of your application and offload some of that I/O off the database so it can better serve write requests. And when I talked about scaling out a minute ago, I talked about the need to separate the reads and writes from the application perspective. You're going to build upon that technique when using a cache in two different ways. So one way is when you're updating the database, your application also needs to be able to update the cache independently and ensure that you have a consistent view across both the cache and the database. You don't want them to grow out of sync. That could become problematic from an application perspective. And Stephen will talk about some of those techniques you can do, caching strategies and their trade-offs in just a little bit. And then you've already gone through the process of handling reads and pointing them at the read replicas. So you now redirect those to the cache to get better read performance. And hopefully our demo helps pull this all together at the end. So that's what I wanted to go over to level set. Now I want to transition into more of an overview of ElastiCache as a service. Many of you are using it, which is great to see, but some of you are not so familiar. So I just want to briefly go over ElastiCache before getting into the profile of Workload, as well as a customer use case of somebody that's successfully gone down this path. So AWS launched ElastiCache back in 2011. And we've spent over a decade investing in providing customers with a fully managed experience, hardening these popular open source distributions for caching, Redis and Memcached. So ElastiCache is fully compatible with both Redis and Memcached. Today we support ElastiCache for Redis version 7, as well as ElastiCache for Memcached version 1.6. ElastiCache is fully managed, as I mentioned, so we have automated cluster management. There's no hardware to provision. There's no software to install and manage. We handle things like maintenance events, patching, and things of that nature. And we also provide the ability to resize on the fly with minimal disruption for applications. So our goal, as you might have heard others say here at AWS, remove that undifferentiated heavy lifting, take care of that for you as a fully managed cloud service. ElastiCache is also designed to be highly available. So you can run ElastiCache clusters in a single availability zone if you want, or you can run in multiple AZs. And when you do, we provide a 4 nines availability SLA for your clusters and your workloads. We also provide additional data protection techniques. So we have things like backup and restore, encryption at rest and in transit, and we have cross-region replication via global data store for ElastiCache. Now, arguably, ElastiCache's killer feature is performance. And performance is a big reason why the open source projects Redis and Memcached became so popular to begin with. So over the years, we've invested a lot in optimizing performance, and that's something you can continue to expect from us. So just as a couple of examples, in 2019, we launched what we call enhanced I/O for ElastiCache for Redis. So what that does is it offloads the handling of network connections onto dedicated CPU threads and improves throughput performance. Earlier this year, with ElastiCache for Redis 7.0, we built upon enhanced I/O, and we called it enhanced I/O multiplexing. So what we do now is we pipeline connections from multiple clients onto those dedicated CPU threads, thereby improving performance. Specifically, up to 72% improved throughput and 71% improved P99 latency relative to ElastiCache for Redis version 6. And just 2 weeks ago, we released ElastiCache for Redis version 7.1. And this time, we basically doubled the maximum performance you can achieve. So we did this by even building more onto that enhanced I/O concept. We're now offloading what we call the presentation layer, effectively command parsing to the Redis engine onto dedicated CPU threads. And we also added in some creative memory access optimization techniques. So with ElastiCache for Redis 7.1, you can achieve up to 100% improved throughput and 50% improved P99 latency relative to ElastiCache for Redis version 7. So all that nets out to about a 2.5x increase in performance in the past year alone. It's really pretty incredible work by the team. And you might have seen earlier a slide for Monday Night Live. The first keynote at reInvent happens in about an hour or two from now. Peter DeSantis will be sharing an exciting ElastiCache announcement later. Unfortunately, I'm not able to talk about it here. He'll also be sharing an announcement about Aurora, among some other things. So you're interested in databases, you're interested in caching, highly recommend you check out the keynote and hear what Peter has to say. So we've worked really hard to provide customers a world-class caching experience that helps you achieve the highest levels of performance and scale. At the end of the day, ElastiCache is all about helping you scale at a lower cost, and that includes when using it in conjunction with RDS and Aurora, our managed database systems. So for the rest of the talk, we'll dig into that. We'll talk about whether adding ElastiCache to your application makes sense, and if it does, how to go about it. OK, so let's figure out how to qualify a particular workload. So one thing you ought to keep in mind when you're trying to figure out, is this application suitable for caching? One easy thing to look at is the read-to-write ratio of your database. Generally speaking, caching benefits read-heavy workloads. Now, your mileage will vary, but we say, if you have roughly 70% or higher reads as a percentage of all I/O, you're likely to see some benefits from caching. And if you have a higher percentage, 80 or 90, you'll likely see even more performance and cost advantages. Another thing to look at is your database inventory of databases that have read replicas, multiple read replicas. And the more replicas there are, the more likely it is that the application will benefit from adding a cache. So if you have multiple read replicas, you've probably done that to achieve a level of read throughput that you otherwise would unable to be achieved if you were using a standalone database without read replicas. And you've already gone through the process of separating the reads and writes in your application. And like I talked about a couple of minutes ago, that gets you partway down the path of what you need to do to make your application cache aware. And again, Stephen will go over those techniques and the trade-offs in just a couple of minutes. So this next point is an important one. Not all reads are created equal. And you want to look at database applications that have a lot of repetitive reads. And ideally, a lot of repetitive complex reads. The more complex the query is, the more important it becomes to pre-compute and cache its results. So what do I mean by a repetitive read? You want to see a query that's being run at a read query specifically. It's being run at a far higher frequency relative to the total population. That's going to be a good candidate for adding a cache. On the flip side, if you have a read-heavy workload, you could have something that's 95% reads, but it's uniform across all the data and all the queries, meaning equal probability for any given query. One of two things might happen there. Either you have a really large cache because you basically have to cache everything, and that's going to increase your cost, or you have a smaller, more constrained cache, and it's thrashing. You're getting a lot of cache misses, and that's going to degrade application performance. That would be the anti-pattern for caching. Spend more money for less performance. That's not why we're here today, right? So definitely don't recommend doing that. And Stephen's going to go over specific tools and techniques you have available to you to identify, here are my databases with a lot of repetitive reads in particular. And finally, if you have a workload where the bill for running that database is comprised of a lot of I/O requests, a lot of request charges. That might be another trigger to go evaluate whether caching makes sense. Now, we do offer native cost optimization capabilities for your request-heavy workloads. We have things like Aurora I/O Optimize that we launched earlier this year. That can help you save 40% on your bill for workloads that have, if you're not using I/O Optimize, 25% or more of your total spend is comprised of request charges. That's a good way to save some money. But ElastiCache can also be a good way to save some money while also improving your performance. So now I'd like to share a customer example, somebody that's been through this journey. This customer is called Wiz. You might be familiar with them. They're a cloud security company. They were founded back in 2020, and they were the fastest software as a service company to achieve $100 million in annual run rate. So that's a pretty impressive growth from them. They do run in the cloud, and part of their service is they provide cloud security. So they take stock on their customers' cloud inventories. And when they started out in AWS, they're using multiple services. They're using things like SNS, SQS, and Aurora. But they weren't using ElastiCache or another caching option. So you think about their application use case. They're evaluating security posture of these cloud resources. What they found was their customer base was growing. They had very rapid growth. The cloud usage amongst their average customer was also growing. So not only are they having more customers, they're having more data from each customer. It was putting more and more of a tax on their database layer. So they saw an opportunity to optimize. So reason being, there's a lot of repetitive reading going on in this workload. If you take a step back for a second and think about this use case, think about your own cloud resource inventories. They're relatively constant over time. You might have some configuration or policy changes. You might be spinning up a new instance or two every day, maybe decommissioning something. But by and large, it's like a common core of things that need to be analyzed. So what they did is they were able to offload a lot of I/O from their Aurora database into ElastiCache. And you can see that in these graphs in the bottom here. They also reduced their cost by 30%. And that includes the cost of adding ElastiCache to the equation. So this is a really good example of realizing the performance and cost benefits of adding a cache. There's a blog out on our website that we published earlier this year. They talk in more depth about their use case, about their application architecture, about the performance and cost advantages, as well as some techniques that they use to optimize ElastiCache itself. So we include a link here for reference in case you want to check that out later. So with that, I'd like to introduce Stephen, who's going to go deeper on some of the specifics here. Thank you.
All right. So the first question you might have is, how do I find the databases that are good candidates? Because you might have a bunch of databases. I've run a lot of workloads on them, but how do I find the good candidates? I can't just go, well, I'm going to add a cache to it, and all of a sudden expect the result. So you don't want to waste your time. You want to do this like a surgical precision to find the right databases. And there are a number of techniques that you could do that. The first one that is available to you without any cost or any minimal intrusion is CloudWatch Metrics. If you were to use our CloudWatch Metrics, this is going to work on self-managed databases or databases that are managed as well. You can look at the I/O rate, the amount of data going in versus the amount of data coming out. That's going to give you a good idea what's the rate of reads to write. It's not going to be very detailed. It's not sufficient, but it's a good start. And if you have nothing else available to you, this is a good tool for that. Now, a better option is to look at very specific engine-specific techniques, because each database engine out there has the capability to help you out. So you have to look at each database engine, and then you get at even more details. In addition to that, if that's not sufficient, if you want more details, our engineers either updated or developed some new tools for specific databases that could help you find really good candidates with projection for results as well. And if all else fails, you're going to hire somebody else. There are third-party tools out there that can help you. So companies that specialize in lift and shift, now they're starting to look at this in a broader perspective, that I'm not just going to do lift and shift, I'm going to look at it, so maybe I could add a caching service as well. So you have a lot of options there. I'm not going to dive into CloudWatch Metrics. It's pretty straightforward, but looking at specific SQL metrics for specific databases, that's probably going to be a lot more beneficial to you. Now, some of the engines that are very popular and run on-prem or in the cloud is a SQL Server. So to find out, for example, a SQL Server, and we're going to get into a lot more detail exactly what you're looking for. In SQL Server, you want to look into this specific table, the query stats table, is going to give you very good results. Why is that? Because every database engine out there keeps a history of past execution. So you want to look at past execution to see what has happened in your database in the past, and you use that knowledge, that information, to project the future. So the next one is on Oracle. If you're on Oracle, again, you want to look in $SQL table. It's going to give you good details. And I'm going to drill in a little bit more, especially in SQL Server, to see exactly what you want to look for and why. If you're already on-prem, you're running a managed database, then you can look at Performance Insight. Gives you good detail. So again, depends on where you are in your journey. You can use different tools, and each one of these techniques is going to help you out. There's not going to be like a catch-all trap. Just do this, and you're going to get your answer. You have to look exactly where you are, what you're using, and then pick the right tool. Now, if you're running a MySQL, maybe a managed MySQL or a self-managed one, then you want to enable the general logging to go to a table instead of to a file, and then you can query it directly and have good results. And finally, I have a PostgreSQL. Again, there you have the stats statements table. You look into that table, and you can have good details in it. So now you know where to look, but the question is, what are you going to be looking for? Because you can't just, these tables have a lot of information. So here's an example. This is from a SQL Server, but similar examples exist for other database engines out there. So what you want to be looking for is the number of query executions and which one is executed the most. So that's one of the columns there. But in addition to that, you want to look at the logical I/O rate. Why is that? Because the logical I/O is the one that captures repetitive SQLs. If it's a physical I/O, that means it was basically a cache miss inside the database and had to go to physical storage. That's not a repetitive query. A repetitive query is the one that executes logical I/Os. So this is going to be one of your biggest clues, because it's going to give you an idea how big of a cache you're going to need, how big of a cache instance, how much data you're going to push through. And the next column there is the average size of these logical I/Os. This is going to be important to find out how big is the payload. So when you pair up your cache, how big of a cache you need for each one of these queries, so you're not going to overspend. So think about the graph that Joe showed you, that the intersection. This information is going to help you where that intersection is happening. Because if you have a lot of small queries that you execute a lot, a small cache is going to make a big difference, so that you're sliding on that curve more to the left. So these are the clues that you have to be looking for. Again, it's not going to be specific for everybody. You have to look at that, do a little homework, and find it out. Next is a tool that was recently released. A couple of our engineers put this together. This is going to help you a lot. This is DB Top Monitoring Solution. This tool is going to help you to do real-time monitoring of your database. So you can see your I/O happening. And the good thing about this product is that it can connect to multiple databases. It can connect to your SQL Server. It can connect to your MySQL. It can even connect to ElastiCache. You can see the throughput of your ElastiCache as well. So you can use it to see how effective is my solution maybe afterwards. Now, this is a free tool. You download it from GitHub. You put it on EC2. You run it when you want it, to turn it off when you don't want it. So the clues here are that you have to run all these tools, all these products, knowing what's happening in your system. You can't just go and say, well, I run my SQL tool, and it says I'm doing a lot of read. I qualify for that. You have to be mindful of that what if a backup is happening on your system? When a backup is running on your database, that's a lot of read traffic going through your system, not a lot of write. But that's not going to be a reflective metrics for the entire application, because the backup was running at that time. So again, you have to understand what your system is doing, when to run these tools. The next one is this tool. We had this for some time, but it has been updated, is a Database Current State Investigation, or DBCSI. This is a tool that helps with your, again, now it's a specific. We started generic, we're getting a specific tool. This is specifically for Oracle. The tool was developed to help with your lift and shift. If you had a self-managed Oracle database, it helped you how to migrate from on-prem to the cloud, your Oracle workload. This tool has been now updated, that it's mindful. It's going to look at the database, past application performance, and it's going to look at your automatic workload repository, AWR reports, and it's going to use that information, again, like past SQL execution. It's going to look at that, and it's going to try to recommend a best path forward. So now you have two recommendations, not just one. So the first one, what it used to do before, what it basically looked at your database and it said, look, based on what you're doing, the size of the database, past workload, we recommend 6 XL instances, 4 of them, to migrate to the cloud. But if your database qualifies, now it's going to recommend basically what we call it a better together, a joint migration that you migrate the database and you add a caching service to it. And you can see it now for the second line is going to recommend only a 4 XL instance, and not 4 of them, just 2 of them, plus adding a cache to it. So, and it's going to recommend the cache size, the cache server, and it's trying to do some calculation how much you might save. So in this case, you're looking close to $6,000 savings. So again, that's a specific tool. So if that's where you are, this is going to help you out a lot. The next tool is RDS Tools. RDS Tools was developed specifically for SQL Server. Again, this is a right-sizing tool. You run it on your SQL Server, and it gives you some information how to right-size it. So you're not basically running too large of an instance. You're not spending money for something that you don't use anyway. By the way, I'm going to share some QR codes at the end of the presentation how to get more information on these tools. So this tool has been updated as well, and now it's going to give you a recommendation that this database is a good candidate, and you could add a caching service to it. So again, all of these tools have been updated. Now you have more information how to go about it. Well, all right, so you've passed this part of your journey. So you found a database, you found a good candidate. You haven't done any changes to your application, no changes to your database. So the next question is going to be, all right, what do I have to do to my application? How do I start to take advantage of this new opportunity that I found? Because up till now, you just did the discovery. So how do I take advantage of this? What do I have to do? So next, we're going to talk about it. What changes you have to make to your application, if you have to, depending on where you are in the journey of your application. As Joe said, if you're already using a separate I/O connections, because you ended up in a position where you did the horizontal scaling, added multiple read replicas, you're partly there, actually quite a bit there. So let's look at some of the techniques and what are the different ways of doing that. One of the most popular caching technique is called lazy loading. Lazy loading is often used with reading, so when you have a lot of read. And it pretty much goes like this, has 3 steps. Step number 1, you're going to read from your cache. You completely bypass your database. So if your data is in the cache, you read it from the cache, and you're not going to bother the database at all. Only if it's not in the cache, you're going to read it from the database. And the third step, you're going to update the cache so that all the subsequent reads, all those repetitive reads, now are going to coming out of your cache. So there are some advantages and disadvantages to this. Everything comes kind of like a balance act. You have to be mindful of that. The advantage is that your cache is going to be fairly small and is going to be very relevant. Only the data, when somebody's asking for it, is in it, and for the duration that you want it to be there. So no unnecessary data and immediate results. You ask for it, it's put in the cache, and the next guy is going to benefit from it. One of the disadvantages is that synchronizing of the cache. You have to synchronize the cache, and the other one is, what if the data is not in the cache? If it's not in the cache, you have to go the traditional way, and comparatively speaking, that is going to look quite different, because now you got used to fast response from the cache. So how do you synchronize your cache? That's one of the questions, and there are many techniques. I will show you actually some code, some ways to do that. One of the easiest ways to do that is to set a time to live of the data. And ElastiCache allows you to set that for each query result individually, not for the whole caching system. So you can adjust it, fine-tune it exactly as you want it. And you want to set this TTL for another reason as well, because if you constantly add data to your cache, theoretically you could exhaust it and run out of space, and then something called an eviction policy is going to kick in, and nobody wants to hear the word eviction. So you want to be mindful of that. So TTL helps you to manage it and also manage the size of it and the scale of it. There are other techniques as well. I'm going to show you that too. So how would you implement lazy loading? How much of a change is that to your code? Well, let's look at that. Assuming that you have a good modular code, maybe you have a function here that is going to fetch data. So first thing that you want to do, you want to calculate the key, how to identify this query. And the key is going to be used to fetch the data for this query. So you calculate the key, and one of the good ways to do that is to use some sort of a hashing algorithm. So it's going to be a unique value as far as hashing is concerned. And next is going to be the next step, basically. Go to the database. Sorry, go to the cache instead of the database. It's a database. Go to your cache and read it. And if it's in the cache, you're done. You're not going to bother your database. That's it. And the else is basically what you're doing right now. Else is you go to your database, you execute your query, and you added one extra line to store it in the cache for the subsequent read. That's at step 3. So again, the example here sets the TTL for the specific query so that A is not going to be stale, and B, you're managing your cache mindfully. The next caching technique, it's very popular, write-through. Write-through is mostly used with updates, kind of like the name implies. And it goes like this. It's fairly straightforward. When you write to the database, you're also going to write to the cache. And that's it. So it's a write comes in, you update the cache at the same time. So what's the advantage of this? Well, there's no stale data. The minute the database changed, the cache is updated. So it's kind of like the advantage of that. But of course, it has to work with your write application. The disadvantage here is that it's possible that you're placing data in the cache that maybe there's no customer for it. Just because something has changed in the database, it doesn't mean that it has to be cached. So how do you solve that? Well, time to live. Again, set a time to live in it so that the cache data is not there indefinitely. And the effects are slightly different. Again, just because you put something in the cache, it doesn't mean somebody's going to use it, or the benefit might be delayed because somebody may not be read for it for another 5 minutes or another hour. How would you implement this? It's probably even simpler than the other one was. First line, now it's familiar. Again, you calculate the key using a hashing algorithm to get a key value. And you use that. And next, you execute your cursor, as you did before, execute your query, and add one extra line. Store it in the cache with the time to live so you can manage it. And you return it. All right, so you passed this part of your journey. So you found a database. Now you have a rough idea what it's going to take to implement it. But the question is, what is the benefit? What's my gain out of this? Because I have to make code changes. It might cost some money. I might have to hire a developer. So now let's look at some examples of what kind of gains you could anticipate. Before you get there, actually, let's look at the size of a cache, because there are many ways to look at the size of a cache. So if you remember your database 101, databases, they cache database blocks, because the databases, they go to storage, and the storage returns an entire storage block back to you. And that storage block, chances are it has your result, your row, plus a bunch of other rows. So it's always going to consume more memory than you need. So whichever way you're going to try to size your database cache or database buffer, is always going to be extra data in it that you may never use. So comparatively speaking, if you use a caching service, when you cache just the result set of your query result, all that overhead is not there anymore. So your cache, based on our experience, is often a quarter of the size. So you don't have to put in a very big cache to get the same benefit. So now let's look at some financial options here. Next, actually going to add some performance numbers. Let's assume that you are on an Oracle database, and everything is working well, and you're somewhere here. Let's say you're running an Excel instance, 4 CPUs, 16 gigabytes of RAM. Life is good, but you have to grow. Your application is growing. You exhausted all the other options. So this is, as Joe said, the vertical scaling. There's nothing else to do. Just turn the button, get a bigger database. Sure, you turn the button, you can double your database right away, but unfortunately, your cost is going to double as well. So that curve that you saw initially, it's not that linear. It's going to jump up. You get more performance, but at 2x the price. Alternately, you can add a caching service to this database. So in this case, I oversize my cache, way oversized, because I'm adding a cache exactly the same size as the next database instance would be. I'm adding 4 CPUs and more than 16 gigabytes of RAM to it. But that is going to cost you only $300. So a quarter of the cost. So you could double your throughput, double your capabilities for a flat fee of $300, or go the traditional way, which is going to cost you $1,300. Now, you might think about it, well, yeah, this is a small example. I'm not going to make application changes. Well, let's look at another example. And this is a bit more detailed. So this is an example when you went the route toward horizontal scaling and you added read replicas because you just needed more read throughput. So in this case, this is a SQL Server example, but it could be other databases that supports multiple read replicas. You went to the work to separate the reads from the writes. So the writes are going to a database that trickles down to the read replicas, and then the reads are coming out from this multiple read replicas. All right, so this is good. This is going to work well. We're going to see the performance and the cost of it. By the way, notice that in this architecture, you have no high availability as far as multiple availability zones are concerned, AZs. Everything is in a single AZ, which is okay if that's what that's what you work with. So now let's look at the new architecture where we replace all those read replicas with ElastiCache and adding high availability in a secondary AZ. So the database now has a read replica, so it's obviously way more secure, not secure, but way more protected, because in the event of a network issue or any kind of a issue related to that single AZ, now you have a second AZ that you can fall over. But the cache itself is also high available. So the writes are going to your database. Now the reads are going to come out of your cache. Here's your lazy loading. You're going to try to read from the cache, and if it's there, it's good. If it's not, you're going to read it from the database once and put it in the cache, and it's going to replicate. So now the cache has itself high availability with multiple read replicas in a secondary AZ. So let's see the cost and the performance, how this thing is going to pan out. So in this case, we tested this in our lab. So if you set this up for your SQL Server, we got fairly good performance. We got 24,000 transactions per second, or TPS, from this configuration. This was for a workload that had 80% reads and 20% writes. And the average response time, the combined average of reads and writes, was 65 milliseconds, and the cost of about $160,000. So now let's look at the new configuration, the new architecture. When we added ElastiCache to it, wow, look at it. The transactions per second went up significantly. So we gained quite a bit of performance there, and the response time went down. But now comes the killer feature, the cost. What happened to the cost? It went down by 67%. So your performance went up, and your cost went down. So now you're saving over $100,000 just on this configuration. So now it's obviously more motivated to do that. Okay, so let's see if I could run a demo. And of course, my laptop has timed out, but I'm going to log in here. So what I'm going to do, I'm going to log in, and I'm going to run a workload that is going to use the database only. I'm going to run about 250,000 queries with the database only, and then I'm going to run the same workload again, but this time I'm going to have a caching service available to the database and try to compare the performance before and after, such as the number of transactions per second and average response time. So here we go. So this is the workload. Scenario 1, when only the database is used. So let's execute this. So while this is running, I'm going to show you the code, what it does, and you're going to be able to see how I manage my caching. So in scenario 1, basically I pick, this is based, and just going to a blog, you will see it. This is based on a publicly available database called AirportDB that we used so that you could replicate it on your own. And we're going to pick a random passenger and a random flight. And we're executing a number of queries here. And what we do, we're going to basically toss a coin, not a fair coin, and try to do either read or write transactions. And if it's a read transaction, that's the first part. We're going to go to the database, bind the query, put in the bind parameter, because that's actually one of the techniques to make your database run faster if you use bind parameters, so that you're not going to parse the same SQL again. So I'm trying to make this as fair as possible. So, again, one of those things that you went through the usual tuning techniques. Bind parameters is one of those so that you could speed it up. So I'm binding my parameters, and I'm executing my query, and I'm just catching the time, how much time it took. And the next one, if it's a write transaction, I'm going to do the same thing. I'm going to bind my parameters and do a write. In this case, somebody's booking a flight. And the first query is going to find out how many times a person has booked a flight in the past. Again, you could use this for anything else that you have out there. You want to project, or maybe some product placement. You want to see how often this past client has been on your website, what it has done. So it becomes a repetitive query. Just the client ID changes, but the query is the same. So we did that. So let's see if the query has completed. No, it's still running. That's all right. Let it run. All right, it has completed. All right. So I'm going to look at its performance statistics. And here it is. So this database was able to execute about, I would say about 2,100, just over maybe 2,100 transactions per second with an average response time of, I would say, about 9 milliseconds. This was an 80-20 workload. 250,000 transactions, 80-20 workload. That was the response. So what I'm going to do next, I'm going to run the same workload, but this time, it's called scenario 2. I'm going to use a caching service. So I'm just going to turn that into a 2 and let it run. And while it's running, I'm going to show you the code. So there we go. Here's scenario 2. Again, we pick a random passenger and a random flight. So that is going to be the same. And the first thing, we're going to calculate the key. Now, there are many ways to calculate the key. I showed you earlier is to do a hashing technique. But in this case, because I know I have a driving parameter, the passenger ID, I have a shortcut. I could just generate the key based on the key, on the passenger ID. So I just prefix it and the passenger ID. So now my key is even shorter. And what do? If it's a read transaction, I'm going to implement lazy loading. And that's that first step. I start my timer, and I'm trying to read from the cache. If I got the data from the cache, I'm good, and I count it as a read. It's a successful read. And I count it as a cache hit. If I didn't get the data because the key wasn't there or it's a new query, then I go to the database and I do what I did before. So the changes was 4 lines before the code. Of course, I have a bunch of timing in there, but that's just for the demo. And then I go to the database and execute what I did before. I bind my parameters, execute the query, and I have a new time. And here's the third step. I store the result in my cache. Now, I could store it without a time, or I could store it with a time. So that would be the example how to store it for an hour. Again, you know your workload. You could set the time for each individual query result. Now, the else statement, line 322, is if this was a write transaction. Notice that I combined the 2 caching techniques for the same workload. The first part, if it's a read, I use a lazy loading. And if it's a write, I'm going to do the write through. I could combine them. Why not? And if it's a write transaction, I know that I have to go to the database. I have to update the database. So there's no reason to go to the cache at this point. So I go to the database. I cook the query. I bind it. I let it run. And then I'm going to do the same thing for the cache. I'm going to execute it in the cache. Now, there are a couple of ways to do at this point. Again, I told you I'm going to show you which way to go about it. One way is just to go update the cache, put the new value in it, just update it. All right? That's an easy way to do it. I got a new query, it's a new query result. I'm just going to go update the cache, flat out. The next one, line 331, I'm going to do the same thing, but with the TTL, a time to live, so it's going to only be available for a period of time. And I have a third option as well, line 332, is what I do. If an update happened in the database, I just go delete it from the cache. So this is one way to manage the cache in a case of a write so that your cache is not growing indefinitely. Either set a timer or just go delete it. Because just because an update has happened in the database, it does not mean that it's going to be a read for it. So this is one way to do that. I'm just going to delete. And the next query that comes in to do a read, well, it's going to get the penalty the first time, as I showed you, the lazy loading. But after that, I collect the benefits. So let's see if the second query has completed. And it has. So let's see the performance. All right. So there you go. Transactions per second went from around 2,100, 2,200. It went up to 3,000. So almost a 50% increase in number of transactions. And look at the average response time. Went from 9 milliseconds down to 4.5. That's the average combined reads and writes. The bottom line there, the blue one, that's the read transaction. That's your reads. When you hit the cache, when you had the cache hit, was sub-millisecond. That's how fast it was. So exact same workload, 50% increase in throughput, and over 50% reduction in response time. All right, so I'm going to switch back now that the demo has concluded. This is the architecture that was used in the demo, so a little recap. So the reads came out of the cache. If it was there, we were good. That's basically the lazy loading. If it wasn't, we went to the database, we read it from the database, updated the cache. If it was a write, then we did the write to both places with the different options. So, little recap. Obviously, that is going to boost your performance. If you qualify, you went to that first step, you found a qualified database, is going to boost your performance. It's going to reduce your application response time significantly. You've seen it, I mean, at least 50%. And if you're looking just at the reads, comparatively speaking, it's at least 10x faster just the reads. I mean, sub-millisecond reads, because it's already there. Another advantage is that you could offload all this unnecessarily I/O from your database into a caching service. So you could manage it there. And what this translates into, fewer database license basically charges for you. Smaller database instances, all of those result into more money in your pocket. And you could slow down your database growth. With that, I'm going to open up a couple of Q&As. And as I promised, here are a couple of QR codes.
Thanks, Stephen.
And here are the various tools that I mentioned.
While you're all taking pictures of the QR codes too, just wanted to ask, please do fill out the survey at the end. Let us know how we did on the presentation. We use these, across reInvent to help us cater future sessions, so your feedback is very appreciated. We will publish this deck online as well, but just, if you need to reach us, here's our personal email addresses, as well as one that goes to the entire team that both Stephen and I are on. Definitely encourage you, if we can't get to your questions, to reach out to us. We'd be happy to help.
Thank you.